But it was the Greeks who first took this innate fascination with shape and turned it into a subject of its own. They believed that by understanding its principles, they could describe the whole world. And they gave a name to this new idea, one which meant measuring the earth. They called it geometry.
The mainstay of Greek geometry was the discovery of 5 perfect shapes now called the Platonic solids, after the Greek philosopher Plato, who believed these were the building blocks of nature. So we've got the tetrahedron with its 4 faces, the cube with its 6 faces, the octahedron with its 8 faces, the dodecahedron 12 faces, and the most complicated shape of all, the icosahedron with its 20 faces. Today, these are more commonly known as dice.
We're all used to the familiar 6-sided dice. But these 4 other shapes have also been used as dice for centuries. What makes them perfect for the job is that they are so regular. The faces of each are all the same shape, all meet at the same angles. It means that there's no way of telling one end from another, and that they are equally likely to land on any face. But most surprisingly, these are the only 5 shapes like this that can possibly exist. They're the only perfectly symmetrical solids.
It's this almost magical symmetry which made the Greeks believe that these shapes were so important. They associated them with the building blocks of nature: air, fire, earth, the cosmos, and water. These 5 shapes built the natural world.
It's very easy to dismiss this approach as naive. After all, it's clear that the world around us isn't made out of just 5 neat geometric shapes. But perhaps we should have more faith in this ancient intuition. Because by laying out the laws of geometry, the Greeks had in fact tapped straight into the code that shapes all nature.
It turned out that the Greeks were right about their shapes, but they couldn't have known it, because the world that is actually governed by their laws of geometry was completely invisible to them. We can find traces of it deep underground. This is the Merkers potash mine in the heart of what used to be East Germany. It's long since stopped production, but you can still explore its 3,000 miles of tunnels.
This is one of the shapes the Greeks were obsessed with. It seems that viruses are too.
Stunning, my God. I've never seen anything like this. In fact, I think this is the only one like this in the world. It's absolutely amazing. It just goes on and on down through the cave.
The cave is full of perfectly cubic crystals that mirror the geometric precision of the Platonic solids.
These cubes are amazing. I mean, look at that. The surface there is perfectly flat, and if you run your finger down the edge here, it's so sharp, comes down to this precise right angle. I mean, an architect would be happy with that kind of precision.
Doesn't look real.
Even if you look inside, you can see just all the cracks are right angles and geometric shapes. Totally surreal. Actually, this isn't anything particularly special. This is just sodium chloride, which we know has salt. This is what you stick on your chips. But, I mean, you don't generally see salt as big a cube as this one here.
How these crystals were able to form with such perfect precision was a mystery until just over 100 years ago, when X-rays were discovered. Our understanding of our biology was transformed by being able to see inside the human body. And when X-rays were shone through crystals, they uncovered another invisible world, one that was both mysterious and geometric. This was the world of the atom. And these neat symmetrical images, called diffraction patterns, can reveal how individual atoms were put together to form the crystals in this cave.
Essentially, you've got to think of these a bit like shadows, just in the same way as an X-ray of my hand is a shadow of the bones underneath the skin. This is a shadow of the billions of atoms contained inside the crystal. Now, it's a little bit more complicated than that, but essentially these are 2D projections of the 3D structure inside this crystal. So now we can analyse these patterns and work out exactly how the atoms are arranged inside the salt.
And there is only one possible arrangement of these atoms that can produce patterns like these. And it too, unsurprisingly, is a cube.
This is a model of the structure of salt. Now, these gold balls are the sodium atoms and the green ones are the chlorine atoms. And it's this atomic symmetry which explains why we're seeing such symmetry in these huge, great big crystals. But instead of just 3 atoms lining themselves up in this model, we've got billions and billions of sodium and chlorine atoms arranging themselves rigidly to create these perfect cubes.
What makes this cave so special is that the perfect geometric arrangement of the atoms has been maintained in these huge crystals. They're a window into nature and how it's governed by the laws of geometry at the most fundamental atomic level. But what's surprising is that we can find the same laws, not just in rocks and minerals, but deep inside ourselves. I've come to the Department of Chemical and Structural Biology at Imperial College in London. Steve Matthews studies how individual atoms are built up into living systems, like you and me.
X-rays are obviously a very powerful, high-energy radiation, so proteins are very delicate. So we cool it down with a stream of liquid nitrogen gas blowing over the crystal.
In this tiny wire loop is another crystal, but this time it's a crystal of protein, part of the machinery of living cells. Just as it's possible to work out the atomic structure of the salt crystals with X-rays, we can deduce the shape of the protein molecules in the same way, though the results aren't quite so easy to interpret.
Now, I'd be hard-pushed to actually give a name to that shape mathematically. I mean, it looks like a blob. But
No, it doesn't have a shape, but many of these blobs come together to form shapes.
So there's a huge amount of structure and symmetry in this protein.
Oh, yeah, definitely.
Yeah, and that's amazing. We've got a cylinder now. This is a real surprise to see geometry at work inside our bodies.
But evolution is, creates a very efficient process. So symmetry is a very efficient way of building, these types of structures.
So by a process of evolution, the biology has discovered that
before us, yeah.
the geometry gives it the best shapes.
Yeah, that's right. But if you really want symmetry, then we can move over to a virus particle. This is...
Now, I recognise that. That's an icosahedron.
Yeah, that's an icosahedron.
This is one of the shapes the Greeks were obsessed with, but
that's right.
It seems that viruses are too.
That's right.
But it's very striking, because the physical world, you somehow expect maybe salt crystals to be symmetric, but the biological world, everyone considers rather a messy one, but this is not messy at all. This is beautiful. geometric shapes which we find at the heart of our cells are the most efficient that nature can produce. It seems like the Greeks could have been right after all. It's their shapes that build the world around us and produce its inherent beauty. An obsession with symmetry and regularity.
The code dictates some shapes through efficiency,
The building blocks of nature.
and others by providing frameworks for the tiniest particles there are.
This is nature's code of work. Seen beautifully in the hands.
What the Greeks discovered in mathematical theory is to be found at the heart of nature, from crystals to viruses. It all seems very neat.
Now I recognise that. That's an icosahedron. I think this is the only one like this in the world.
But our world isn't filled with precise geometric shapes. It seems random, disordered. To find out why, we need to look to the sky and the crystals that fall from it. Snowflakes assemble themselves in the heart of frozen clouds and fall to Earth in a dazzling display. And if there's one thing we know about snowflakes, it's that they're all perfectly symmetrical.
Wow.
Here we are. It's the snow lab.
Physicist Kenneth Liebrecht has created a lab for growing and photographing these perfect crystals.
After the Greek philosopher Plato, who believed these were the building blocks of nature. So we've got the tetrahedron with its 4 faces, the cube with its 6 faces, the octahedron with its 8 faces, the dodecahedron 12 faces, and the most complicated shape of all.
Used to the familiar 6-sided dice. But these 4 other shapes have also been used as dice for centuries. What makes them perfect for the job is that they are
The icosahedron with its 20 faces. Today, these are more commonly known as dice.
We're all used to this new idea, one which meant measuring the Earth. They called it geometry.
The mainstay of Greek geometry was the discovery of 5 perfect shapes now called the Platonic solids.
But it was the Greeks who first took this innate fascination with shape and turned it into a subject of its own. They believed that by understanding its principles, they could describe the whole world. And they gave a name